All right. We're going to get going in just a minute here. Cool. All right, cool. So as usual, welcome to Study Hall. We've got, last time we left off on doc strings. So just a quick rundown as usual. This is a place for you all to bring your questions and ask questions, and I'll take them on stream. Just to provide a link to the problem in Learn, and I'll be able to take it quickly, answer it quickly on stream. Cool. So last time we left off on doc strings. Since I'm not seeing any questions at the moment, I'll just go through the material. We were talking about the importance of leaving some documentation in your code. This is not something you'll see me do often, because mostly what I'm doing is just sort of writing quick example functions for you all. So, but when you're working on a bigger project, it's very useful to be able to write doc strings to include documentation in your work. And I gave a quick example of this last time. I'll give that example again here. So if we use the help function, let's use the help function on something, how about sum? The sum function. So if I want to know more about the sum function, I can pass it to help. Notice I'm not invoking it and passing it, a list of things to sum like I normally would in order to use the sum function. But so if there's any library or data type or function in Python that I'm curious about, we could do the sum function, or we could do like the int data type or list or whatever. But we'll just stick with functions for now, since that's sort of more relatable to what we're going to show. I'll just run this, and usually I'll do this in the terminal. You could do this in the terminal or in a document like this. And then it's going to print out the help docs on the sum function. So there's my, oops, let's just do this. There's my internal documentation for sum. So it says sum takes in some iterable, takes in a reference to, takes in self, has another parameter called start, which defaults to 0, and it says returns the sum of start value default 0 plus an iterable of numbers. Oh, that's interesting. I never knew that it returned that. Oh, I see. It was just worded weirdly. It's just saying it starts at whatever the start value is and then just iterates through. So when the iterable is empty, return the start value. This function is intended specifically for use with numeric values and may reject non-numeric types, right? So this is going to tell me about how the sum function works. So not too much there, we don't necessarily need to know about sum. That's a way we can access internal documentation. And we can actually do this with our own functions too. So if I say def my, see if I can hit my Y key. Oh my gosh. Okay, my function, and I'll just leave a doc string here, and I'll say, oops, I'll say this is my function, takes in parameters, and I'll do this. returns a value, whatever. And let's just give it some parameters so we can actually see. And then I could get help on my function, and we'll see the little docstring that I print out here. So it says my function A and B. This is my function, takes in parameters, returns a value. So you can see this is, when we leave in a docstring, we make the documentation accessible to anybody using our library or our code, right? So I could build a library of tools that I use, and if I, or for a certain purpose or whatever, turn my project, whatever project that I end up doing, into a library of the tools that I use to do it. And if I could share that library, or if somebody wants to use that library of my code, if I documented everything, they could kind of learn how to use it by using the help function, and or just looking through my code and reading the documentation that I left behind. So it's nice that Python will associate the docstring. It's not with the function, and it's not just there in line, but it's accessible actually outside and in other places. Cool. All right. Yeah, let's just jump into the challenges here. So let's see. Which of the following reasons should you write a docstring? So in order to help you communicate with the future you that looks back on the current function that you're writing, this is a great reason. It's funny how little time needs to pass before you look back at your code and it doesn't look familiar anymore. I've had it happen a number of times where I write some code, and then a few days or a week later I'm reading through it and it doesn't look familiar, so or I don't remember writing it. So if there's the way that I write is fairly regulated and predictable, so I kind of know, I have a sense of how to read my own code. But even still, if I end up having to do something funky or something outside of what I would normally do, maybe there's a good reason to do that. It's useful to leave a little bit of documentation in there to remind me what I was thinking and what I was doing. So anyways, so in order to help others use your function, so I'm just going to say all of the above because these both look good. And this says, as a form of self-control to make sure your functions don't become overly large. This is actually a great reason as well. Yeah, that's so one thing you will see me do is like take in problem statements. And I'll do this with the material off Learn or off Code Wars, or I'll write my own problem statements in my own coding, and they essentially just turn into docstrings. And I always try to include inputs, process, and output. And I'll usually actually do it like this: process, input, output. I try to hit these marks, and then if there's any other notes that I need to know, if it causes a mutation in some type that propagates, where that mutation is seen outside of the scope of that function, I might note that. Yeah, so I'll just take some notes like that, but mostly I'm just worried about hitting these three marks and just input, process, output, or process, input, output when I'm writing a docstring. So you'll see me do that as I copy paste in problems from Learn. Cool. Yeah, and just on the note of this as a form of self-control to make sure your functions don't become overly large. Just taking a few notes on what you intend a function to do can really help save you a lot of time, so you don't end up trying to write it in such a way that it's supposed to do everything. You just scope it to one specific task and another specific task. The thing that I think goes along well with this is writing tests, right? So just a simple test you can write with print, and then you can call your function name something like that, and then you could say, well, I don't know, let's actually add 10. We'll just do this. Add 10. We'll just take in A, and we'll return A plus 10. Okay. Okay, so this will return 25, right? So for this, I'll say 25. So something like this, just where you have some small input that you can, get as close to being able to calculate the whole thing in your head. Obviously, this is just adding 10, so this is not a big deal. But when we get into like functions that start returning large lists or large dictionaries, you might not want to write out the whole thing. You might not want to like go through and like solve a whole lot of small math problems by hand in order to get an exact result. So just take some note that gets you close. In this case, we can be exact, and be exact if you can, but you just want to give yourself something to give you the idea of what your function is supposed to return. And between writing a short doc string that encompasses process inputs and output, and writing a test where you're declaring that for some input we should expect some output, some specific output, these will help keep you focused on what your function's actually supposed to be doing. It's really easy without doing something like this to like orient yourself around what you're trying to end up with. It's really easy to just go off the rails and start trying to write a function that does everything. So yeah, anyways. Okay, cool. What are the three basic parts of a docstring? Description, step-by-step guide, and return. Step-by-step guide, parameters, and return. So that, description, parameters, and return. Yeah, so this is basically what I'm talking about process, description, input, output. Same deal. I just, I don't know, process or description. I learned it as input, process, output, but you could do it this way. Yeah. Cool. Complete the function according to, excuse me. Complete the function to the docstring specifications. Okay. Let's see. Collat's calculator. Initial val. So this function calculates the Collat's conjecture from a starting value. This function should half the number if it's even. Okay. I'm just gonna kind of rearrange this. Oops. So if the number is even, should half the number. Okay. The number is even, half the number. If the number is odd, multiply by 3 and add 1 to it. This process should repeat until the number is 1. Okay, so we still have an initial value. Okay. So we'll do while, and I'm just going to rename this. I'm going to call this n. While n is not equal to 1, we will see if n mod 2, mod 2 equals 0, then it's even. Then we'll say n equals n over 2. Else it's odd, so we'll say n equals n, I think it's times 3. Times 3, let's just check that. Okay. If it's even, half the number. If it's odd, multiply it times 3, multiply by 3 and add 1. Okay. So n times 3 plus 1. Okay. The process should repeat until the number is 1. We have our n, and we're supposed to return data tup, which is a tuple. Okay. Tup, which is a tuple. And I'm going to return tup. This tuple should contain the start value, the largest number reached in the calculation, the number of iterations it took. Okay, let me bullet this. Tuple of start value, then largest number reached in the calculation. Number of iterations it took to reach the value of 1. Okay. So let's just call this I for iterations. We'll start this at 0. And we'll say I plus equals 1. So this is going to be our count. And instead of having a tuple here, like this, I think I'll just have 3 variables and return them with commas, and that'll return a tuple. Okay, so our start value is going to be n. Now I'm using n in this calculation here. So why don't we do this? I'll just rename this. That had a different name initially. What was it? Initval, I think. Yeah, initval. I'll go back to initval. And we'll return initval. The largest number reached in the calculation. Okay. So let's see. We'll just assume, we'll say largest number. Oops. We'll just start it at n, and I have to make n exist, so I'm going to say n equals initval like this, and this will just copy it. Since integers are immutable, I don't have to worry about this not copying. So I'll have two values that are the same. So initially we'll start the largest value at n, and then at the bottom here we'll say if n greater than largest, I'm just going to call it largest. If n is greater than largest, largest equals n. Okay. And we're going to return largest as well, just like that. All right, cool. Hopefully that'll do it. Might be a little bit of tweaking necessary, but let's give it a run, see if it passes the tests. Maybe we'll get lucky. And if not, we'll adjust accordingly. Oh, okay, cool. Got it on the first try. So let's see, I want to see how their solution differed from mine. Looks like it's actually probably exactly the same. So val in calc, yeah, this looks like the value that they're calculating internally. Largest val and num iterations. So val in calc I'm calling n, and they're doing the same thing where they're just initializing it to init val. Largest val they're actually initializing to init val. I'm initializing it to n. Same difference though. And then num iterations I'm calling I. So different variable naming, but same basic gist. While val and calc not equal to 1, this is the same. We're gonna count. That's where I have I, and they looks like they just have the largest val calculation happening first, but I guess in this case it doesn't matter if it's at the bottom or at the top, but yeah. So this appears to be exactly what I wrote, just with different, basically with different variable names and just slight stylistic changes. Cool. All right. Seems like we have a few people with us on stream. Welcome. If you have any questions, feel free to put them in to Slack in there. Yeah. You don't have to like necessarily wait for a good time or anything. You know, just I think some people would feel like maybe they're interrupting if I'm in the middle and they don't want to interrupt. But I'm really, just so everybody knows, you know, I'm going through the material as going through the material is secondary to being able to take people's questions. So definitely bring in your questions. You know, that's mostly what this is about. Okay, parameters versus arguments. Of course, we did this. Parameters versus arguments. By the end of this lesson, you'll be able to know when to use the word parameter or use the word argument. So this is just going to explore a basic concept of functions having to do with when we define a function versus when we invoke the function. So when we talk about functions, we'll talk about, you know, len being a function, or sum being a function, or whatever, range being a function. We'll talk about these various functions and call them functions. We'll also talk about functions that look like this. Factorial, you know, that where we talk about the definition and we talk about the invocation, sort of like the same thing. But a function you can think about it like it's a system that isn't complete until you have a definition and an invocation. If you try to invoke a function that doesn't exist, that doesn't have a definition, you're going to get I think a name error. You'll get some kind of error. I believe it'll be a name error. And if you try to, run a function that's defined but that you're not invoking, that's valid. It's a valid thing to do. I can define this function and then run it. I can define this function and execute my code, but it's not going to run anything. And let's just look at that real quick. Right, so here I have a function that's defined. If I run my code, it's not going to yell at me. It's not going to say, hey, you can't do that. But it's also just not going to do anything because I'm not asking it to do anything. This is not a request for Python to execute instructions. This is a definition of a process. Python's going to look at this and say, oh, well, I've got this process here. So anywhere where I see factorial, I suppose I'll just perform this process. So if I want it to actually perform the process, I have to tell it, yes, we have the definition. Now actually execute the instructions in the function. So we'll do factorial 4 here. Okay. So now this is a complete system, right? So when you're thinking about functions, when you're writing your own code, generally you'll be writing in functions. You'll be writing most of your code inside of functions, and then at some point you're going to have to invoke that code. It can be just outside of the function in the global scope here, or you can invoke the code in another function. So functions are allowed to call other functions within their definitions, right? So this is the distinction that I want to emphasize, right? The distinction between the definition of a function and the invocation of a function. Or sometimes, I always use the word invocation, but sometimes I think it's more common to refer to this as a function call. It's definitely more common. But it just gets confusing calling something calling, because I talk about what things are called, and then I talk about function calls, and it's like, wait, what does call mean in that case? But usually it'll be called a function call. So we have our function call and our function definition. So when we're defining or calling the function, we have this idea of an input into the function. During definition, we refer to that input as a parameter, right? So n is the parameter into the function. And then 4 is the argument, right? So when I invoke the function, I pass it an argument. When I define the function, I specify parameters. And that's the difference between parameter and an argument. Something to take note of here, while we're defining the function, the parameter is like the name part of a variable, right? So it's the identifier. It's an identifier without a value, right? At no point in here does n acquire a value. Even if you might see me do this with other functions. Often that'll take in a list, def sum function will take in a list, and you might see something like list equals list dot copy, right? This is still not giving a value a novel value to list, right? There's still no point, so even if there's a reassignment, it shouldn't be a reassignment to some value. It's probably some transform of the current value, or maybe it's hidden under a condition, which tests other values, other parameters or whatever. But so if you've done this correctly, your parameters take on no value during definition, essentially. And then if you look here, right, this is the value that we want that parameter to have. So if you think about it like a variable, n equals 4, what makes a function useful is the fact that we can specify a name that does not yet have a value during definition, the parameter. And then when we want to actually run the function, to supply values for those parameters when we invoke it. And that makes the function dynamic. Cool. All right. Let's go through this. This is actually a good point here. The terms are often used interchangeably, and it's something that I do. It's something that I believe you'll see Tovio do. It's something that we all do, and we, in a in an industry of people, being, very pedantic and exact. It's like this mistake that we all collectively make, and nobody cares. So it is important to know the difference, right? The reason it's important, and the reason I framed this way, the reason it's important is because you want to have a clear distinction between a function definition and a function invocation, right? A function definition is describes a general process, and a function invocation invokes that general process with specific values and produces a specific value, or performs some specific action, right, according to its inputs. So that's really the idea to grasp here, is functions describe general processes. The reason I would say they describe a general process is because the parameters don't have values, right? So this is a process, right? This describes how to do a factorial for some value of n. We don't know what that value of n is. During definition, we have no idea what the value of n is going to be. But this describes, if we knew the value for n, this would tell us how to take the factorial of n. So that's a general process. And this might look specific. This might look like a specific thing, but when I say general, I just mean that we don't know some specific value yet. So this will solve a problem for a set of values, of n. And then when we invoke the function, sort of the opposite. Hopefully we know what to expect on the return, or if it doesn't have a return, we know to expect the process to do. We know what effects we expect calling this function to have, and we essentially know or are determining specific values to give to the function to perform whatever its process is. But we kind of don't care about the process, And the useful thing about this is I can just think about this as factorial of a given number, and I don't have to think about this, prod equals 1 for I in range 2 to n plus 1, prod times equals I return prod system every time I just want to do factorial, right? So I don't have to write that whole thing out. Anyways, so the important thing to grasp there is that even though you will hear us usually refer to everything as arguments. We'll talk about arguments and sort of use that word laissez-faire to mean parameters or arguments. In any case, there is a distinction, and the importance of that distinction, in my opinion, is to have that clear understanding between, or that clear distinction established between the definition and the invocation. Okay. So what's the best way to describe the difference between parameters and arguments? Arguments are variable names known only to the function. Nope, that's wrong. Parameters are variable names known only to the function. That's right. Arguments are the values passed into the function that are stored in the parameters. It'll be that one. Let's just read these other ones. Parameters and arguments are essentially the same thing. Arguments are values inside a function. Parameters are variables. No. Cool. So consider this function signature and mark the correct choice below. So here's a bit of an exception where I was saying parameters don't take on specific values. We do have some really cool things that we can do with parameters. We can set a default. So I need to think of, whenever this comes up, I always just kind of end up making something up. I need to just think of like a little project that I can demonstrate the sort of utility of defaults. But basically a default makes passing this parameter as a passing an argument for this parameter optional. So if for whatever reason I wanted to just default to factorial 4, I can just leave out the argument when I call it, and since I defaulted it to 4, it will assume that I want to use 4. Right? Now, of course, if I want to do something else, if I want to overwrite it, I can do that. So if I pass in a value, it'll use the value I passed in, and if I don't pass in a value, it'll use the value I set as the default. Cool. All right, so let's read through this. 11 is the parameter and the function of the function find divisors. That's not correct. N is the argument and the parameter of the function. N is the parameter of the function find divisors, and 11 is the default argument. 11 is the argument passed to the function find divisors, and N is its default. No. So N is the parameter, and N is the parameter, and 11 is the default argument. So true or false parameters are the values passed into the function. That's false. Cool. Multiple parameters and default arguments. Let's look at this. I wonder if there's a good example in here somewhere. Okay. So what this is going to get at is using multiple parameters with default arguments. And this might seem like just sort of trivia, like why would we even cover this? But there is a bit of a trick here. Something to remember. And let's see here. Let's just do a simple function, def add nums. We'll take in A and B, and we're going to return the sum of A plus B. And then we'll print add nums. We'll take in 10 and 15. We'll get 25. Okay. So here's our super simple function. So we don't have any defaults. Let's say I wanted to default. I wanted to be able to use this function with one number. If I pass it only one number, I want it to assume to add only one, to add 1 to that number, right? So I could default B to 1 like this. And I get 11. So I pass 10, I get 11. So this, if I pass two numbers, I'll add the two numbers. And maybe, let's call this increment. We'll call it increment. And yeah, let's call it increment by. Increment by, right? So if I don't supply a second argument, it's just going to increment by 1. It's going to assume that I wanted to increment by 1. Now you might ask, why B, why not A? So if we look at this, now first of all, let's establish something here. So first of all, let's look at this. I have a function that takes in 2 arguments. I'm invoking it. I'm giving it no arguments. This is an error. Oops. So type error, increment by, missing 2 required positional arguments, A and B. So when you invoke a function, you have to supply arguments for all the parameters listed. There has to be a value given. Otherwise, what does that even mean? So if I say I take in 2 arguments, there better be, or 2, if I define 2 parameters, there better be 2 values that I can use for arguments. So I could default 1 if I want to use it with 1, and we'll get a similar error if I only pass in 1 argument here. So if I try to default the first one, and you might think, oh, so if I supply only 1 value, since it has a value given for A, it's going to put this value in for B, right? And that's not what's going to happen here. That's not going to be, or excuse me, that's not what's going to happen here. So we get a special error just for this case. This is a syntax error. It says non-default argument, B was a non-default argument, follows default argument. So this specific thing is no good. Python won't allow it. So if you have default arguments, you can have a function with multiple arguments. You can default multiple arguments. But if some of the arguments are not defaulted, the non-defaults have to precede the defaults. So I can have as many default arguments as I want, but they all have to be on the right-hand side. They all have to be after the defaults. So that has to be here. And now this will work. Now, of course, if I wanted to increment by some other number, I could do that here. Cool. All right. So that's something that's worth remembering. If you're going to use default arguments, just keep them on the right-hand side of your list of parameters. Okay, default arguments. So what will be printed to the console after this code executes? So we take in a name and an age. The default is 18. Our invocation takes in Jane Doe and 25. So this should say, hello, I am Jane Doe, and I am 25 years old. So see if there's any. Oh, that's got an F in front of it. That's kind of trying to trick me. Looks like that one. Which of the following, or which of the below would be considered, quote, too many parameters? I mean, this one. Okay. So this is an interesting thing. There isn't a limit on the number of parameters a function can have, but hopefully, if you're looking at this, hopefully you can see like this is a lot of parameters. I have written functions where I have passed in this many or close to this many functions or parameters. It's kind of nice. Defaults kind of make it really nice. You know, if I default a whole bunch of parameters, essentially I have sort of configuration information that I can pass as needed rather than like having to pass 10 items at once. So I've actually done stuff like this, but I am definitely of the mind to try to avoid this if at all possible. You know, you don't want to end up writing a function that takes in an insane amount or a whole lot of arguments. Just think about the way to think about like what's too many is like when you go to invoke it, how many things do you want to pass to it? Like just in terms of what feels like too much, you know. As a rule of thumb, 3, maybe 4 is a good limit. 5, I guess, if you had to, but more than that, and you start having to think, okay, do I really need to do this? Can I rearrange my code where, you know, I have this in other functions? And most of the time, I think you'd find the answer is yes. You can rearrange your code to not have that much. But there was a project that I did where I built a couple functions that just had a lot of parameters. So, and I stand by it. I stand by that being the right thing to do in that circumstance. But anyway, Cool. So what value will be stored in the is Pythag? Pythag? Okay. After the code is run. Okay. This function takes in all three sides of, like Pythagorean. Okay. I was thinking like this was a misspelled Python or something. I was like, wait, Pythag? But that makes way more sense. So this function takes in all three sides of a triangle, tests to see if they are a right triangle, then checks to see the guess in the form of yes, it is true, or no, it is false. Okay. Okay. So let's see here. I don't know Pythagorean theorem off the top of my head, so I'm shooting in the dark on this one. Let's just see if there's anything in here. So true, because it is a right triangle and the default value of right try guess is true. Oh, okay, so a squared plus b squared equals h squared. So let's just look at this. So if we do 5 squared is going to be 25. Then we've got 16 and 9. That actually is 25. Okay. So this is going to be a right triangle, but the guess is false. So this is saying 25 equal to 25. This expression is true. So true equals false is false. So it's one of these two. False because it is a right triangle and the value of right try guess is false. Yes, that's the one. Okay, cool. Alright, so by the end of this lesson, you'll be able to review the return keyword, be able to return multiple objects from a function. So when we talk about a function returning multiple objects, what's really happening is it's returning a tuple. But we have this other way of talking about a function returning a tuple by saying it returns multiple objects, and it just, what we mean is that it returns a tuple that contains multiple objects. So don't let that fool you. This is not a difficult idea. It's just a function that returns a tuple. Okay. So as you know, the return keyword is used to return an object from a function. For example, So note that this is not the same as we have this function. So if you look at this function has a problem with it. And that problem is that the return is not inside the function. It's below the function, but it's not inside the function. So in order for it to be inside the function, it has to be tabbed in. If we have a return, let's just look at this. We'll get this error. So this is another, oh, actually, there we go. We get a syntax error. It says return outside of function. So we can't have a return that's not inside of a function. In order to put it in, we have to tab it in. All right, so the code immediately above is incorrect. The print function, okay. Okay. So this is an interesting thing. So using the code syntax return print whatever is always wrong. So yeah. I will see people try to do this or something similar occasionally. Or you try to return a print, or where you omit the, somebody will try to omit the return and use a print instead. And print and return are very different things. Return gives a function a value. Print makes something visible on the console. So we can call a function, and if we don't print anything, nothing's going to be visible on the console. And if we print inside of a function, we're just making something visible on the console. It doesn't mean that we're saying that that function has that value. We're just logging those things to the console, so it doesn't really give it a value. All right, let's just jump into these challenges. So what's the best way to describe the difference between returning and printing? So print returns, print prints and returns the value. Nope, that's not what it does. Return returns and prints. Nope. Print prints to the console for the user to see. Return returns a value from the function to be used later. That'll be that one. All right, so write a function, Write a function named accumulator that takes an integer as its only parameter and returns two objects. An integer that is the accumulation of adding all positive numbers up to but not including the argument supplied. Okay. Let's just get a test here. So accumulator 4 is 1 plus 2 plus 3, not plus 4, so 1 plus 2 is 3, plus 3 is 6. And then let's do 5, which is going to be this plus 4 is 10. Okay. Def accumulator takes in some number, and ACC equals 0 for I in range 1 to n. ACC plus equals I return ACC. Okay, so I know it's supposed to return two things, so this one says a list that is the running total of the accumulator at each stage of the loop. Once you've written this, unpack the output. Unpack the output of the accumulator into variables total and running total. Okay. Let's just make sure this is going to work as stated for 6 and 10. Okay, good. Oops. Okay, so that'll do that. So now let's do a list equals an empty list, and I'll just list dot append ACC. Then we'll return ACC and list. Oops. Okay, so I'm not sure if list is supposed to have 0 in it, because ACC does start at 0, so let's see if this works, and if it doesn't, then maybe I'll put a 0 in the list and see if that helps it. Nope, okay. Has no attribute total. Ah, right. I forgot to do this. Okay. Six is not equal to 45. Alright, let's see what's going on here. Whoops. So let's say I want to see if we get a 45 somewhere. Yeah, there we go. Okay, so for 10 we get 45. And it looks like we're supposed to be getting a 6 in some place. So let's see what's going on here. Line 16, unpacking tuples. Main.total equals 45. So it should equal 45, but we're getting 6 instead. Interesting. So I see. I didn't read the last steps. Assign the output of the accumulator 15 to the variable my tuple. So I have to actually write these tests out in order for Learn to be happy with it. Okay, so once you've written this, unpack the output of the accumulator 10. There we go. Should just read the whole problem. No biggie. And then this one should be called, what was it, my tuple? Okay. That did it. Okay, cool. Write a function called item collector to the following specifications. So the first parameter, called list, is a list of items to collect. The second parameter, called item, is an item to be looking for inside the list. The function should return two things: the number of occurrences of the item, and the indices of that item, presumably as a list. Return the number of occurrences of item, return a list of the indices. Okay, cool. All right, cool. So let's say indices list equals list. Oh, excuse me. What am I doing? Indices list equals empty list, and then count, we'll call this item. Item count equals 0, and we'll say for IDX element and enumerate list. We'll say IDX if element equals item. If element equals item, IDX list dot append IDX, and item count plus, oops, I have to pull this over here, item count plus equals 1. Then we can return, what was it, the number of occurrences followed by the list of indices. Okay. So here's one way to do it. Should be, we'll see, yep. And then another way we could do this item count is we could just use the count method. So I could say list.count item. And that'll do the same thing. Saves a little bit of code there. All right. Okay, KISS, which is keep it simple, please. Yeah. Hopefully this is a self-evident principle. But basically, the idea is, there's no reason to write overly complex code, other than maybe if you're just trying to explore some specific idea, which is fine early on. But ultimately, the ends of what you're trying to do usually are served better by simple steps that get you from A to B consistently. So these are some analogs. There are a few analogs to this that deserve some space. So simplicity is the ultimate sophistication. Brevity is the soul of wit. Make simple tasks simple. Occam's razor. a problem-solving principle that states entities should not be multiplied without necessity. Okay, cool. We'll just skip this one. We're going to get into Args and KW-Args in here. Cool. All right. So by the end of this lesson, we want you to be able to use and understand the star args and the KW args for functions. So you may notice the suspicious little function that we use all the time, the humble print. Something funny about print is it takes as many arguments as you give it. Of course, you actually have to write it out correctly, which I didn't. Okay. Oh, still didn't do it. Yeah. So print takes n number of arguments. Let's actually look at this. Let's call help on print. So you can see print's function head is actually kind of complicated. There's some stuff going on. I'll just paste that in there. And some of this is sort of shorthand for other things. It's not exactly what print's actual function head looks like wherever it's written. This, for example, means star args, which we're going to talk about today. So separator ending for the line ending when print is done printing. Yeah, so there's quite a bit going on with humble old print. So let's look at one of those things. We're not going to look at all of that, but let's look at one of those things, which is star args. So star args, if I write a function, let's do a function, something like def, we'll just do a summing function, sum all. And we'll take in nums. I mean, we could do a list or something, but there's already a function called sum that does that. So instead, I'm going to say nums, and I'm going to say for num in nums, res plus equals num, res equals 0, return res. Okay, and real quick here. So when I go to call this function, sum all, I get to pass it as many arguments as I want. So I can pass it one argument, pass it none. So I can pass it no arguments. Notice there's not a default here. I could pass it a bunch of arguments. And this isn't a list. I'm not passing it a list. I'm just passing lots of individual arguments. Sometimes this is useful. You want to write a function that takes in something and then some unknown number of other arguments. This can be a really useful thing to do. All right, cool. I'm actually going to kind of read through this because there's a few little odd things about this. So a few lessons ago, you learned that generally speaking, you want to keep the number of parameters in a function definition relatively low. However, there are some cases where you want the user of your function to have the ability to pass in an arbitrary number of arguments. So star args. KW args is something a little bit different. KW stands for keyword args, and we're going to get into that in a second. But yeah, they're definitely related here. So basically what this allows Python to do, at least star args like this, and by convention, when you have a starred parameter like this, star args, you call it args. You don't have to do that, but that is the convention, and that's usually how you'll see it. Obviously in this case they were all going to be numbers, so I thought nums would have been better. So you don't have to call it args, but you can, and that's the conventional thing to do. So and calling it args doesn't do anything additional or special. It's just a name like any other name. So star args. If I print the type, or let's just print args. We'll print args just like that. And if we look, we get these arguments, which are just the arguments that I passed. And they're surrounded by parentheses, which tells me it's a tuple. And we can confirm that by doing type. And that'll tell me it's a class tuple. Right? So it allows the function to treat its arguments for star args as a tuple. I can use this in conjunction with other arguments too. Let's say I wanted to take in a string for some reason. We'll do that. Let's do that, just like that. Okay, so notice the hello is not considered to be part of my star args, right? And that's because the first argument is going to get consumed by this first parameter that I specified here. So hello gets consumed by string. So if I print out string, I'm going to see hello. And then if I print out args, I'm going to get all the rest of the arguments. What's interesting, I can't have non-defaulted or non-keyword or defaulted arguments after star args. So if I do something else like some other parameter, some other param, I don't know. Yeah, this is going to give me an error. Yeah, it's funny because it'll give me this type error, sum all missing one required keyword only argument. So you might be familiar with this error or a similar error that says sum all missing one required positional argument. This doesn't say positional, instead it says keyword only, and that means I can't access this argument without specifying it by keyword, because as many arguments as I continue to pass to this function will just continue to be consumed by star args. So if I wanted to specify a value for this, I have to use a keyword. So I'll say some other param equals, we'll just say value. And since I specify by keyword, I can do it anywhere. Oh, no. Scratch that. I can't do it anywhere. I do have to do this at the end. I don't do this kind of thing often, so it's a little bit of, I'm testing my memory a little bit doing this. It can be really powerful, though. It can be a really cool thing. Cool. So this is the way that I can supply a value to this final parameter here. Often, if I write a function that, say, takes in a couple values every time I call it, but has like a lot of defaulted parameters, and I don't want to overwrite them, a lot of times you'll put in, let's look at this, config 1 equals 0. So imagine I had a bunch of configuration parameters here where I was kind of calibrating or tuning the function to a specific task, to a task that I thought it was going to be used most often with. Right? So I could tailor this function to some specific task, and just to be careful so that I don't accidentally add too many positional arguments and start overriding the defaults that I have as configuration information to the function, I can just do star. I don't even have to give it a name. I can just do a star like this. And this will protect these from being overwritten via positional argument. And it means that the only way to access these is via keyword argument now. So that can be a really cool thing to do. So you can have your regular positional arguments and then a star, and then just defaulted arguments for all your configuration stuff. And so these are the things that you want to assume every time you run the function usually, but you might want to overwrite them under certain circumstances. You might want to do something special with them, or override one of them in a given case. So I could override config 2 with some other value if I wanted to do that. And they're going to be protected by the star args here. Yeah, I got rid of args. But since, let's do this. Oh yeah. There we go. So that's something that you can do with star args. This I do find myself doing on occasion. And this is a really cool thing to be able to do. If you ever have the thought like, oh, should I make this thing a parameter? Maybe, or should I just assume a value for this? But I might sometimes want to use it as a parameter, but I don't always want to pass it in, right? Protecting that as a defaulted keyword argument behind a star, an unnamed star args, will, yeah, that'll do that for you. So this is a really useful thing, and in my own coding I do use this fairly frequently. Okay, so we talked about star and star args. So let's look at KW args. So this is kind of a funny one. I just kind of butchered that function. Let's do this. we only got a few minutes here. So remember when I said we'll do def some function. If I do star args, it's going to treat the arguments as a tuple. If I do star star, then it's going to treat those arguments as a dictionary, which is kind of funny. We usually call this KW for keyword args, KW. And I'll do this. I'll print the type and KW args. And then when I invoke it, well, I don't need to do it in a print. I'll do some function. Now I get to supply custom keyword names, but I have to also, right? So I can't just say 4, 5, 6. So some function takes 0 positional arguments, right? So if we look at this, some function doesn't take any positional arguments, but I gave it 3. It doesn't tell me it takes keyword arguments, but you know. So let's call this arg1 equals arg2 and arg57. So if we look at this, KW args, the type of KW args is a dictionary, and the keys were the argument names. Now this as strings. This is a really weird thing. It's a very, very peculiar thing. I know of nowhere else in Python where the name of a variable will get converted at any point to a string like this, other than here. This is a really peculiar kind of behavior. So here we have, you know, notice this is not in quotes. I believe it actually could be in quotes. Let's just test that. No, it can't be. Expression cannot contain an assignment. Yeah, okay. Wait, can we do this? So I thought I've done this before. Can we do it like that? Nope. Okay, nope. Can't do that. So they have to be like, they have to be a name, like an identifier style name, like a variable name without quotes around it. And then in the function, they get given specific names like this. So this can be really useful if there's like other configuration information that you only want to pass in if a certain name is given. It's a lot like what I was showing up here, where you can select a keyword argument like this while you're calling the function. But yeah, in this case, the argument names get determined when the function is invoked, or the parameter names get determined when the function is invoked. The only parameter name, proper parameter name in here is KW-args, and then the args are essentially the parameter names, and yeah. So I haven't used this as often. I've seen some people do some really cool stuff with it. I haven't found it as directly useful myself, but it's really cool, and it's there if you should want to use it. Okay, cool. I think I'll save these for next time. It's 5:30, so this is our normal stopping place. Yeah. Thanks for everybody who hung out and watched. Hope you enjoyed it. I'll be streaming again this Wednesday, so I'll see you then. And if you're in Premium Prep, then I'll see you this evening. I'll be teaching this evening. Cool. Y'all have a good rest of your day, and I'll see you on Wednesday.